Well, we have arrived at the final topic that we're going to cover in this class. This is section 12.5, and the I can statement is I can find mean absolute deviation. The word here is deviation. So let's warm up by talking about what absolute value means. Remember, absolute value means the distance from 0. When we talk about the absolute value of a number, we're talking about the distance from 0. And then the question is, why is absolute value always positive? And that's because distance is always positive. If absolute value is distance, and distance always positive, then absolute value always has to be positive. Okay, and what does the word deviation mean? Now, we could deviate from course. We could be off course a little bit. I'm going to put that in quotes, off course. When we deviate from our course, we depart from our normal course. Like if you deviated from your normal course to school, you would take a different route to school. So if you depart from normal, depart from the normal, and I'm going to put course on here. So if we depart from normal, that's called a deviation. Okay, that would put us off course. All right. Now, we're going to kind of talk about this before we actually do any of these. This is going to seem maybe a little bit strange, but I think once you get used to it, you'll kind of see why they called it this funny name, and you'll see why it might be useful. So, we've talked a lot about different ways to analyze data. Two very common measures that we might be interested in are measures of center. We talked about a whole bunch of those, and measures of spread. Measures of center and measures of spread. So measures of center are things like mean and median and mode. When we were talking about the center, we were talking about what typically happens. So if we were to guess, on average, what typically happens with this situation, whether they're test scores, mile run times, whatever it happens to be, we're talking about what typically happens. And then measures of spread are things like range and quartiles and interquartile range, which remember we kind of abbreviate with an IQR. So that measures how spread out the data is. Both the range, the quartile, and the interquartile range all measure spread, whereas mean, median, and mode measure the center. Now remember, statistics is the science of making decisions using data. And the statistics that we've already talked about, they're not quite sophisticated enough to handle some of the situations that we might have to run into, or decisions that might need to be made. So one way we can measure spread that's a little bit more sophisticated is by computing something called the mean absolute deviation. The mean absolute deviation. Now, there are lots of times where mathematicians will name something that if you think about the words and what they mean, they kind of help you figure it out. So let's break this down a little bit. We're talking about the mean absolute deviation. Well, when we talk about mean, what we're talking about is the arithmetic average. So let's just call it the average. And absolute would be the absolute value of something. So we're talking about the average absolute value of the deviation. And the deviation is the departure from what we normally get, or what we typically get, or the departure from the mean, the arithmetic average. Okay? So it's the average, and right here we're going to say distance, because remember, absolute value refers to distance. It's the average distance from the mean. And remember, the mean is a way of talking about the center. So when we talk about the absolute mean deviation, what we're talking about is the average distance that the data points are from the center. And that's all this is that we're talking about. We're just coming up with a different way to measure how spread out they are. If they're really spread out, they're going to be a long distance from the center, and if they're not very spread out, they're all going to be a pretty small distance from the center. So the mean absolute deviation is a measure of how much variation there is. Variation. Variation is another way to talk about how spread out things are. Okay. In other words, on average, how much does the data vary from the mean? Again, how spread out is it? It's a little bit more complicated than to compute than range and quartiles and interquartile range and stuff like that. But again, usually things that are more complicated to get are actually more useful. Now, this is, by the time we're done with this, I'm hoping that this is pretty easy for you. But you'll be, if you can do this, you can actually understand some measure of variation that you're going to talk about when you get in ninth grade, called the standard deviation. Okay, so when they use the word standard, that's a really typical thing to do, is find the standard deviation. Really important thing. If you end up taking more statistics or something like that, standard deviation is really important. So we're going to run through some relatively small data sets, and I'm going to show you how to find the mean absolute deviation. I've already got a table set up, so here's what we're going to do. We're going to write down the data in this column right here. So we've got a 3, a 3, a 5, and a 5. Now, we need to figure out what the mean is, so there are actually 4 of these. So we're going to add these together, 3 plus 3 plus 5 plus 5, and then we're going to divide by 4. So that happens to be 16 divided by 4, so we end up with 4. So the mean, the arithmetic average, is 4 here, 4 here, 4 here. Now, when we find the deviation, we want to know how far from the mean we are. So we're going to find the data minus the mean. That's going to be the deviation. It's always what we observe minus whatever the mean is. So we're going to do 3 minus 4, so we end up with -1. And then we're going to do 3 minus 4 again, -1. We're going to do 5 minus 4, that's going to be +1, and we're going to do 5 minus 4, that's also +1. So again, I told you it was pretty easy. We're going to write down the data points right here. We're going to find the mean for the data set. We're going to put that right here. And then we're going to find the difference between each one of those data points and the mean. So in other words, we're going to figure out how far they are from the mean, and the sign right here is going to represent the direction. So for example, 3 is 1 below the mean, and 5 is 1 above the mean. That's why these are negative and these are positive. Now, the absolute deviation is exactly what it's talking about. It's the absolute value of whatever this number is right here. So that's a 1, that's a 1, that's a 1, and that's a 1. So remember, absolute value refers to distance. It doesn't care which direction, it only cares about distance. So how far is this one from the mean? Well, it's 1 unit, it just happens to be below, but it doesn't care when we're taking the absolute value, it just cares about how far. So each one of these is a 1. Now, we add all of those up, we get 4, and then to find the mean, we're literally averaging those 4. So we do 4 divided by 4, and we end up with 1. So this right here is the answer. This is the mean absolute deviation. Now, I'm going to do one more, and then we're going to come back and we're going to take a closer look at this data set and its mean absolute deviation. And we're going to take a look at this data set and its mean absolute deviation. So let's run through and do this one then. So here's what we've got on this one. We've got 0 and 2 and 3 and 7 and 8. So you'll notice that there are 5 pieces of data on here. If we add these up, we end up with, let's see, this would be 0 plus 2 plus 3, that's going to be 5. That's going to, another 7 is 12, so this would be 20. Okay, so if I add all those up, I get 20. I'm going to divide by 5, so I end up with 4. So lo and behold, on this one, we end up with the same mean. We end up with 4. So I'm going to do 4 here, 4 here, 4 here, 4 here. Now we're going to do the deviation. Again, it's going to be the data point minus the mean. So it's going to be this one minus that one. So that's going to be a -4. That's going to be a -2. That's going to be a -1. We've seen that calculation before. 7 minus 4, that's a 3. 8 minus 4, that's a 4. Okay? Now, we're going to go ahead and find the absolute value of that deviation. So basically what's going to happen is we don't care whether they're positive or negative. We're just going to make them all positive because we just care how far, not which direction, whether they were above or below. So this is a 4, this is a 2, this is a 1, this is a 3, and this is a 4. Now we're going to add those up. So let's see, we get 6, we get 7, 7 plus 3 would be 10, 10 plus 4 would be 14. So the sum is, the sum is 14. Now the mean absolute deviation means we're going to take that sum and we're going to divide it by however many there were. Remember, there were 5. So we're going to divide by 5, and if you do 14 divided by 5, I think you're going to end up with 2.8, but let's just double check and make sure. So we'll turn this on, clear this off. We're going to do 14 divided by 5, and we end up with 2.8. So the mean absolute deviation on this one is 2.8. Now, if we just look at these data sets right here, this is 3 and 3 and 5 and 5. The mean is 4. This is 0 and 2 and 3 and 7 and 8, and the mean is 4. Look at the mean absolute deviation. The mean absolute deviation, or one of the measures of variability, or one of the measures of, we could say the measures of spread, is 1, and the measure of variability on this one, the measure of spread on this one, is 2.8. So since this has a bigger mean absolute deviation, this probably has more variation among it, more range. The numbers are more spread out. Okay, so we're going to put data set B has more variation. Okay, in other words, okay, or that is more spread out. Now, if you're having any trouble seeing that, we're going to give you a little help here, because take a look at what example 1 star says. Draw a dot plot for each of the data sets in example 1 above. So here's what we're going to do. We're going to draw a dot plot. So I'm going to do 0, 1, 2, 3, 4, 5. I'm going to do both of these at the same time. Okay, so I've got these all set up. This says do a dot plot. I'll go ahead and do a dot plot, but let's see. So we'll do from 3 to 4. We've got 2 of these values, and none in the 4s, and then we've got 5s right here. Okay, I'll do a histogram also. I'll just put those in a box right here. Okay, so that's what that histogram or dot plot looks like. And then on this one, let's see, we've got a 0. So 0 to 1 I'm going to put like this. We've got a 2, so that's going to go from 2 to 3. We've got a 3, that's going to go from 3 to 4. We've got a 7, and then we've got an 8. Okay, now if we just look at these two data sets, you can see that they're more spread out. All 4 of these points are between like 3 and 6, if you wanted to say that on this number line right here. So they're all bunched right around here, right around that mean of 4. The mean on this one was 4, but look how spread out they are. There's one down here at 0, there's one way up here at 8. So they're really spread out, so you can kind of see that they're spread out. So the one with the larger mean absolute variation or deviation, that's the one with more variation, or that's the one that's more spread out. Okay, let's flip the page over. And this one says compute the mean absolute deviation and show all work. Now you'll notice on this one that there is nothing else on this page. So that means we've got to figure out how to do this. So we are going to construct a table like we did before. So we're going to have our data. We're going to have the mean. Let's see, what did we have on that other page? What went right here? This was the deviation. And then we took the absolute value. In fact, I'm going to do this. I'm going to use the symbol. I'm going to use the absolute value of deviation. Okay, so that's what we're going to keep track of. So here are the data points: 75, 95, 80, 110, 88, 120, and 180. Now these are pretty darn spread out. Okay, let me make sure I've got them all. I've got 7 here. Do I have 7 there? I do. Okay, these are all pretty well spread out. I mean, the smallest one is 75, the biggest one is 180. That's a big spread. So we're looking at finding a big measure of spread, a big measure of variation. We're looking for a large mean absolute deviation. So I'm going to go ahead and add these up. Okay, so I've added these up. I got 748, and then I divided by 7, and I got 106.85. Now for the purposes of this, and just to make this a little bit easier, I'm going to go ahead and round to the nearest whole number. So I'm going to call this 107. So I'm going to write 107 in each one of these. Okay, so I went ahead and wrote down 107 in all of these, and then I just used the little quote marks to show that all of these are 107. We found the deviation by doing whatever the data point was minus the mean. So it's 75 minus 107, we get negative 32. 95 minus 107, we get negative 112. Let's take this big one right here. 180 minus 107, we get positive 73. Now, the quick part here is just going through and figuring out what the absolute value of the deviation is. Because remember, we don't care which direction. We don't care whether it's positive or negative, below the mean or way above the mean. We just care how far it is. So this is going to be 32, 12, 27, 3, 19, 13, and 73. And then we're going to add those up. Okay, so you'll notice that I added them all up. I ended up with 179, so I'll put 179 right here. And then we're going to divide that by 7 because we want the mean absolute deviation. So we added those all up. We're finding the average deviation. So we went from 32 to 12 to 27 to 3 and all sorts of stuff. We've got those as the average, the deviation for each one of those. So we add them up and divide by 7 to find the average deviation. And we ended up with 25.57. So let's go ahead and round to the nearest tenth. We're going to call that 25.6. So 25.6. So that is the mean absolute deviation. So this is the largest absolute deviation we've gotten so far. So you remember on this one right here, they were pretty tightly packed together. They were all 3s or 5s, so they weren't very far from the mean of 4. These were a little bit more spread out. So the mean was 4, but the mean absolute deviation was 2.8. So a little bit more spread out than those. But then this one is really spread out. This one has a mean absolute deviation, or in other words, an average distance from the mean of 25.6. So these are great practice problems. They're good to get you in the mode of kind of working with data, working with relatively simple formulas. We go through, again, we write the data, we write the mean, we subtract the mean from the data. So we go ahead and do it in this order. Find out what each one of those are, positive or negative. Make them all positive because we just care about the distance, and then find the average of that, however many pieces of data there are. And again, the bigger this is, the more variation there is. The smaller that is, the less variation. Or in other words, there's less spread if it's a small number, there's more spread if it's a big number. Okay, good luck with the assignment.